In this chapter, we're going to start talking about probability. This is our first section, so it's just an introduction to probability. To begin our discussion, we need to define a few terms. First, a trial or probability experiment is any process that produces a random result, such as drawing a number from 1 to 10 out of a hat. This example easily illustrates the possible individual results called outcomes. For this example, all numbers from 1 to 10 are outcomes. The set of possible outcomes is called the sample space for that experiment. For the example of drawing a number from 1 to 10 out of a hat, the sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Example 1 says, identify the sample space for each of the following experiments. Notice that the outcomes in a sample space are listed between brackets and separated by commas. So, looks like our answer is already here, rolling a single die. So the sample space would be the set of all possible outcomes for the die. One with a 1 on the side, one with 2, 3, 4, 5, and 6. Birth order gender for 2 children in a single family. So we want to list all the possible outcomes. You could have a boy and then a boy. You could have a boy and then a girl. You could have a girl and then a girl. Or you could have a girl and then a boy. Notice how we put the braces on either end and it's separated with commas. That is part of the notation for a sample space, so that's important. So we've already discussed those definitions. An event is a group or subset of outcomes in the sample space. And classical probability is the number of possible outcomes in the event divided by the number of outcomes in the sample space. So how many possible outcomes could there be over the total possible outcomes? Suppose you were asked to draw a card from a standard deck of 52 cards. A standard deck of cards contains the following. We have red cards, they're the diamonds or the hearts. There's black cards, they're clubs or spades. There's 13 in each suit, so 13 diamonds, 13 clubs, 13 hearts, 13 spades. And they start with an A, and then 2, 3, 4, 5, 6, 7, 8, 9, and is it 10 or 0? I think it's 10. And then we have Jack, Queen, and King. What is the probability that the card you draw is red? So we want the probability for red. We'll need the total number of red cards over the total number of all the cards. So we know the total number of cards is 52. If we look back at our picture, we can see, if you count them up, 26 of them are red. So the probability that you draw a red card is 1/2, or you could change that to a decimal, 0.5. Do make sure that you reduce your fractions. Whether or not Hawks decides that you should put in a fraction or a decimal, it will tell you, okay? What is the probability that the card you draw is a diamond? So we need to look and see how many diamonds there are. If we count them up, there are 13. And that reduces to 1/4, or as a decimal, 0.25. What is the probability that the card you draw is a face card? So let's see, there were 3 in each suit that were face cards, so that would be 12. And that reduces to 3/13, or as a decimal, approximately 0.230769. And what is the probability of drawing a red spade? Oh, I'm trying to draw it so that I don't have to write it out. But so a red spade, let's look back here. All the spades are black. So there is no probability that you would draw a red spade. Suppose that you grab a snack from a bag of chocolates that contains 4 caramel with milk chocolate, 4 peppermint with white chocolate, 6 dark chocolate with mint, and 2 raspberry with dark chocolate. What is the probability that you randomly grab a raspberry with dark chocolate for your snack? The first thing we need to do is to find the total number of chocolates here. So we'll add those up. 4 plus 4 plus 6 plus 2, there's 16. So we want the probability that you'll draw a raspberry with dark chocolate. So there's 2 raspberry with dark chocolate out of 16, and that'll reduce to 1/8 or 0.125. Empirical probability is the number of times an event actually occurs over the number of times the experiment is performed. So with empirical probability, most of the time you're looking at an experiment that has been performed. So the first one, classical probability, that's sometimes called theoretical probability, is based on theory. It's what you expect to happen. Empirical is based on something that an experiment or something that you've actually been performed to try out. For her elementary school science fair project, Libby is conducting research on the accuracy of weather prediction from her local news channel. She recorded the forecast and the actual weather for 2 weeks. The following table shows her results. So the forecast for the first day was rain, and it actually rained. The forecast for the second day was a chance of snow, and it rained. That seems to happen a lot here in the mountains. And then the third day, the forecast was snow, and it actually snowed, and so forth. Using empirical probability, what is the probability that the news channel accurately predicts the next day weather? So we want the probability of a correct prediction would be the number of correct predictions out of the number of days recorded. So let's see, how many days did she record? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 days. And we want to see how many of those were correct. So this one was correct. There's 1, 2, 3, 4, 5, 6, 7, 8. 8 correct. And we can reduce that to 4/7 or 0.5714229. And so you could actually say that the probability that the news channel is correct is about 57%. They're correct about 57% of the time. Not very good. Determine if the scenarios given are examples of classical or empirical probability techniques. Katie is curious about her chances of winning an e-reader from the Student Government Association. She polled her friends to find out how many of them filled out the survey to be entered in the contest. So, this is a survey, which is similar to an experiment. So this would be empirical. Tristan is interested in his chances of winning at the blackjack table. He determines the probability of what his next card will be by knowing the cards that have already been played. In this case, all cards have an equal chance. So this is classical. Based on the recent United States Census, the local government estimates the amount of growth the community will experience in the coming years. This is an incomplete account. It's not based on every situation possible. So since it's incomplete, it is empirical. And that concludes our first section on probability.